These are your guided notes for lesson 4.4, solving two-step inequalities. What we have here is just an example of what a two-step inequality looks like, which is right here. Didn't get well. Right here, so two-step inequality, we have 5x minus 4 greater than or equal to 11. So again, what makes it an inequality is that it doesn't have just an equal sign there. It's got a greater than or equal to sign. And it's two steps because in order to get the variable x by itself, we have two numbers, two things we need to get rid of, the minus 4 and the times 5. So you can see in the work, in the example, the first thing that we're getting rid of is the constant, and we're getting like terms together. So 11 and the minus 4 are like terms. We want to get them on the same side, and since the goal is to get the x all by itself, then it makes sense to get rid of the minus 4 and move it over to the other side, as opposed to getting rid of the 11 and bringing it over to the left so with the x. So to get rid of the minus 4, again, to get rid of things, we always do the opposite. So the opposite of subtracting 4 is adding 4. And you can see whatever you do to one side, you must do the same thing. Got this line here to give you that visual, left side and right side of your greater than or equal to sign. So when you add 4 to both sides, the minus 4 and the plus 4 are opposites. So they're going to cancel each other out, which leaves the 5x on the left-hand side. And on the right side, you have 11 plus 4, and 11 plus 4 is 15. So what we've got, in that first step, when we get rid of the negative 4, this is what's left over. 5x is greater than or equal to 15. So now we want to execute the second step, which is to get rid of the coefficient, in this case 5, and the 5 next to the x means multiplication. And the opposite of multiplying is dividing. So you just draw that line underneath the 5x, making a fraction, because all fraction problems are division. So we're dividing both sides by 5. The 5's will cancel each other out because they would equal 1. 5 divided by 5 is 1. So you'd end up with 1x, and 1 times x would be x. Anything times 1 is itself. So the 5's cancel, and you have x left over. You've got your greater than or equal to sign, and then we have 15 divided by 5, and 15 divided by 5 is 3. So our answer to solving that inequality is x must be greater than or equal to 3. And the graphing is down here. We have a solid dot because it can be equal to, because of this sign right here, the or equal to. We color in the dot, and it says x must be greater than or equal to 3, so we shade everything to the right, which is this arrow right here. All right, so let's take a look at a couple of these problems then. First example, we've got b over negative 3 plus 4 is less than 13. So our two steps, first step is always combine like terms, and in this case they are constants, which is the plus 4 and the 13. So again, if we draw that line straight down through the sign, dividing left side and right side up. Again, ultimate goal is to get the variable, in this case b, all by itself. So first thing I'm going to get rid of is the plus 4. To get rid of plus 4, I would subtract 4. Again, opposites. So subtract 4 from both sides. Plus 4 and minus 4 cancel each other out because they equal 0. And b over negative 3 plus or minus 0 would just be b over negative 3. Bring down your sign, which is less than. Do the math on the right side. 13 minus 4 is 9. Now to get the variable b by itself, we need to get rid of the negative 3. And that means b divided by negative 3. So the opposite of dividing by negative 3 would be to multiply by negative 3. And if I multiply the left side by negative 3, I have to multiply the right side by negative 3. So our times negative 3 and our divide by negative 3 cancel each other out, leaving the variable b all by itself. On the right side, I have 9 times negative 3, which is negative 27. And then if you remember the rules from lesson 4.3, anytime we multiply or divide both sides of the sign by a negative number, we have to flip the sign around. We have to reverse the sign. So I multiplied the left side by -3, and I multiplied the right side by -3. Therefore, the less than sign becomes a greater than sign. So my answer is B is greater than -27. And then it says to graph the solution. So if we just make a simple graph, here's 0, -27 would be to the left of 0. We have an open circle because B is not allowed to be -27. It has to be greater than, so we don't shade the circle in, we leave it open. And all the numbers greater than -27 are to the right. So I draw an arrow from that circle to the right. If you think you got this, you can give example 3 here a shot on your own. Hit pause, go ahead and give it a try. I'll work through the answer now. So following all the same process, we have 3p plus 2 is less than or equal to 32. Draw a line right down the sign, dividing left side and right side up. Again, we don't want to get rid of the coefficient first. In this case, the 3, we want to get rid of all the constants. We want to get those like terms together. So I want to get rid of this plus 2 first. How do I get rid of plus 2? The opposite of adding 2 is to subtract 2. So I subtract 2 from both sides of the sign. Plus 2 and minus 2 cancel because they equal 0. And 3p plus 0 would be 3p. Bring down your sign, less than or equal to. Do the math. 32 minus 0 is 30. Now we want to get rid of the 3. It is multiplying your variable, and the opposite of multiplying by 3 is to divide. Again, that line just makes a fraction. Fractions are division. Top divided by bottom, so we get the divide by 3. And if I divide the left side by 3, I have to divide the right side by 3. So the 3's cancel because they equal 1. So we have p all by itself. 30 divided by 3 is 10. So I divided both sides by a positive number, therefore I am not flipping the sign. I am leaving it less than or equal to. So my answer is p is less than or equal to 10. And it says to graph it. So again, just a basic number line. 10 is going to be on the right side of 0. And in this case, it has the or equal to, so our variable is allowed to be 10. So I put a solid dot at 10, and it says p has to be less than or equal to 10. All the numbers less than 10 are to the left of it. So closed circle, shade left. Next page, the only difference on this one, and you learned this in the last chapter, distributive property. So this one actually takes 3 steps to solve. So you have the -7 on the outside of the parentheses, x plus 3 inside, is less than or equal to 28. So the first thing you would want to do is distribute this out. Other ways of solving this, but we've been focusing on distributive property. So -7 times the x would be -7x, plus -7 times the 3 would be -21. Is less than or equal to 28. So now again, our goal is to get the x by itself. So we would get rid of the -21 first, our constant, get rid of that first. So the opposite of 21 negatives is 21 positives. So I know it's got an addition on there, but since you're adding negatives, we don't want to subtract 21. To get rid of 21 negatives, we would not subtract 21 positives. We would add 21 positives. Positives and negatives cancel each other out. So we're adding 21 to both sides of the sign. These 21s cancel because they equal 0. You get -7x is less than or equal to 7. Oops, sorry. I'm adding the 28 and the 21. So I would get 49. So now I still need one more step to get the variable all by itself. In this case, I need to get rid of the -7. That's not a subtraction sign, that's -7. It's multiplying. The opposite of multiplying by -7 is to divide both sides by -7. So negative 7 divided by negative 7 is positive 1. So again, that would leave you with 1x. And anything times 1 is itself, which would be x. And 49 divided by negative 7 is negative 7. And again, you can see right here that I divided both sides by a negative number. Therefore, I must flip this sign. So the less than or equal to becomes greater than or equal to. So that's my answer to solving this inequality, is that x must be greater than or equal to negative 7. And right below that, example 5, it tells you which graph represents the solution. And it's the same problem that we just solved. Negative 7 times the quantity of x plus 3 is less than or equal to 28. So again, we know that our dot should be our answer. If we flip back, our answer was x is greater than or equal to negative 7. X is greater than or equal to negative 7. So we know we should have a dot on negative 7. So A meets that requirement. C does not. It's on positive 7. B meets that requirement. Dot is on negative 7. D does not. It's on positive 7. So we're down to A or B. And it says that x must be greater than or equal to negative 7. All of the numbers greater than negative 7 are going to be to the right. So that's choice B. So we can eliminate A. B is your answer for what's the graph of that inequality. So on your next page in your notes, you got some problems that you can work on your own there. We realized that that should be problem number 3 there. So you've got 4 problems plus a little additional question down there at the end. So solve those and bring those back to class with you.